Howdy y'all, it's Areeba.
And it's Darshini, and we're going to be teaching you how to solve problems involving vertex-edge graphs. A vertex-edge graph consists of points and line segments. This specific graph can show you the possible routes between places. We have vertices on a vertex-edge graph. So the definition of a vertex is a point that serves as an endpoint or not part of an edge. It can represent a place. And we also have edges. An edge is a line segment connecting the vertices of a graph. It can represent a distance. In this graph that I've drawn here, we have vertices and edges. So the vertices that we have here are A, B, C, D, E, F, and G. And we also have edges, which I have labeled for you. We have AB, AD, BC, CD, CG, GF, FE, and EC. Sometimes you can find a route that uses every edge of a drawing just once. This type of continuous route is called a path. So in this table, I have written out rules that can help you look for paths. So for an example, I drew the picture of a zoo tour. And so there are two possible routes or two possible paths for this tour. You can go from A to B to C to E to D back to B where you started. Or you can go from B to D to E to C to B and then to A. So those are the two possible paths. Now there are also types of vertexes. So an odd vertex is when a vertex has an odd number of edges. So for example, right here, the vertex A, it only has one edge. One right here that leads to B. Now, B also has an odd number of edges because look, this is the B vertex. 1, 2, and 3. It leads 3 different ways, or like there are 3 different edges. And then there's also an even vertex. So an even vertex has an even number of edges. So for that we have D as a vertex, we have E as a vertex, and we have C. Each one of these vertexes have 2 edges each, as you can see. So yeah, those are basically the 2 kinds of vertexes. Now, I have also written out rules. Now, these rules apply for finding paths. So right here we have for 2 odd vertices. So when you're looking at a diagram like the one I've drawn here about the zoo tour, when there are 2 odd vertices. So if there are 2 odd vertices, there is a path starting at one odd vertex and ending at the other. Meaning, alright, so right here we have types of vertexes, right? So we have an odd vertex and an even vertex. We are talking about 2 odd vertices. So we have A and B as 2 odd vertices. So we have A and B. So there is a path starting at one odd vertex and ending at the other. So in this diagram, we have that shown, right? Because there is one odd vertex and another one, and there's a path between them. Now, for the second rule, we have more than 2 odd vertices. Now, in a diagram, if there are more than 2 odd vertices, there is no path. And to go around the drawing completely, you must use some edges more than once. So if there are more than 2 odd vertices, so let's say, not in this specific zoo tour because we only have 2 odd vertices, but if we were to have more than 2 odd vertices, let's say C was an odd vertex, that means that you would have to go around the drawing completely, and some of these edges may be used twice. So like B to C might be used twice, or B to A might be used twice. And we don't want that. but that's basically showing paths. And then we also have only even vertices. Now, there is a path called a circuit that starts and ends at the same vertex. Now, a circuit tells you that the path must come back to the starting point. So we have only even vertices, right? So there is a path called a circuit that starts and ends at the same vertex. So if A and B had weren't odd vertexes, then this rule would apply to this Zutor diagram, and we would have something which is called a circuit. And I said before, a circuit starts and ends at the same vertex. So basically, these are just a few properties of finding paths in a vertex-edge graph.
The Johnson brothers, Keaton and Wesley, walk with their friend Andrea to school every day. Andrea always arrives late to their house. Find the shortest route she could take from Keaton to Wesley's house. Also find the shortest route for them all to go to school from the Johnson household. First, you need to find how many vertices there are. 1, 2, 3, 4, 5, 6, 7. Next, you need to find how many edges there are. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 edges. Now we need to find out the shortest route from Andrea's house to Keaton and Wesley's house. You go from A to B to C. That's 4 miles. Or you can go from A to G to C, which is 3 miles. And that's the route we're going to take because it's the shortest. Now we need to find the distance from Keaton and Wesley's house to the school. You can go from C to D to E, which is 3 miles. From C to G to F to E, which is 4 miles. Or from C to G to D to E, which is 5 miles. We're going from C to D to E because that's the shortest route. So the first answer would be from A to C to G, and then the second answer would be from C to D to E.
A photo message is sent from computer A to another computer on the network. The message is then forwarded to every other network computer one by one. Which route allows each computer to receive the photo message just once? Now, in this type of question, you would have to find the total possible ways to connect the computers, but in this specific question, we are given the answers, so all we have to do is guess and check. So let's start with A. Now, A gives us the route of A, B, C, D, E, F. Alright, so it goes from A, B, C, D, E, F. Alright, this works because every single computer receives the photo message just once, as it says in the question. Now, for B, it says the route would be A, B, C, E, D, E, F. So let's try that out. A, B, C, E, D, E, F. E, F. Alright, what have we noticed? This route from E to D gets used twice, which is something that we don't want, because we want every computer to receive the photo message just once. So B wouldn't work. And then we have C. Now C is A to C, then C to E, then E to A to B, B to C, C to D, D to E, and then E to F. Now, none of the edges are used twice, but what have you noticed? A has 3 vertices, 3 edges going out, right? That means that the computer A, got the photo message multiple times, which is something that we don't want. Now, for the last one, that's a long one, but for D, it would be from A to C, then C to D, D to E, E to C, then C to A to B, B to C, C to A to F, and then F to E. Great. Now, this is one where A to C gets used 3 times. This right here gets overlapped 3 times, which is something that we definitely don't want. So after trying out all the answers, we found out that A is the answer because each computer gets the photo message just once, and that's exactly what we want. So yeah, A is our answer.
For this first independent practice, we need to find whether A is an odd vertex or not. This is vertex A. Is it an odd vertex or not? How about E? This is vertex E. In the second independent practice, we need to find how many roots there are from A to B. This is A, and this is B. So you need to figure it out.
So for the past few minutes, Areeba and I have been teaching you about vertex-edge graphs. So what did you learn from us? Now we can review. So I drew a vertex-edge graph to the left, and so let's find how many vertices there are. Now there are 4 vertices. We have A, B, C, and D. Let's find how many even vertices there are. We have C and D as even vertices. Why? Because both C and D have an even number of edges. They both have 2 edges, 1 and 2, and then D also has 2 edges. Now, which vertices have an odd number of edges? We have A and B that are odd vertices because A has 1 edge and B has 3 edges. So they both have an odd number of edges. A has 1 and B has 1, 2, and 3. Alright, now let's find how many edges there are. That's pretty easy. We have A, B as an edge. We have BC, CD, and DB. Those are our edges in this vertex-edge graph. Now, do we have a path in this vertex-edge graph? Well, let's see. We do have one path because with only 2 odd vertices, there is a path. And the possible path is A, B, C, D, B. A, B, C, D, B. That's our path. Because what do we have? We have 2 odd vertices. And that makes a path. What is the possible path? A, B, C, D, B. That is our path. And that was the review. And I hope you had fun learning with Areeba and I. Thank you.